Hello students, today we are understanding virtually experiment determination of chloride content of a given water sample by using Mohr's method. Apparatus for this experiment are burette, pipette, conical flask, measuring cylinder and beaker. The chemicals required for this experiment are zero point 0.1 normal standard silver nitrate solution, distilled water, potassium chromate indicator and sample water. Theory related with this experiment is natural water contain many salts in the form of chlorides like calcium chloride, magnesium chloride, aluminum chloride, sodium chloride, etc. etc. During water softening process, if such type of chloride containing water is used, then it may introduce certain salts in the form of sodium, aluminum, calcium, etc. etc. Also, these chlorides undergo hydrolysis and produces hydrochloric acid. This hydrochloric acid, for example magnesium chloride, when react with water it form magnesium hydroxide and hydrochloric acid. This hydrochloric acid is very hazardous for the boiler because its presence make that corrosion of that boiler or etc etc. So this Mohr's method is very useful. In this process silver nitrate is used as a titrating solution. Initially it react with chloride and forms silver chloride. So as soon as the titration going on, all the chloride ions react with this silver nitrate and get converted into silver chloride, which is white colored precipitate. So when all the chloride are simply converted into silver chloride, then the indicator molecule is nothing but which one? Potassium chromate. So potassium chromate contain chromate ion. This chromate ion react with silver and forms brick red color precipitate. So as we know that any substance get precipitated when its solubility product is exceeded, so it means that its solubility produced product is exceeded and hence it has brick red color. So this brick red color is nothing but the end point of the titration, because we start the titration with water and that water is colorless. So when colorless solution get converted into brick red, then this is the end point of the titration. So in this case this is just a theory about that experiment. How that particular titration is take place, we will see by using this procedure. So let us start the procedure by taking part 1, that is standardization of silver nitrate. For standardization purpose we use sodium chloride as a standard solution. So take 10 ml of 0.5 normal NaCl sodium chloride solution in a titration flask or conical flask. Add 1 ml of potassium chromate indicator and then titrate this sodium chloride solution with silver nitrate solution. We have brick red colored precipitate at the end of the titration. Simply suppose that we take in a burette, that is nothing but simply silver nitrate, okay, and in conical flask we take water sample. It is colorless initially, but when we add silver, simply when we add within that water potassium chromate, it get yellow color. Look at that beaker. As you see in this video, beaker shows yellow color solution. This solution indicate that water contain chlorides. So when such a chloride containing water is then titrated with silver nitrate, then we will definitely get the amount of chloride content. So part 2, determination of chloride content in the given sample. We will take 100 ml of water sample in a conical flask, add 1 ml of potassium chromate in a indicator in a conical flask. We will have yellow color solution. This yellow color solution obtained in a conical flask is titrate with burette solution, that is silver nitrate solution. So when we add drop by drop silver nitrate solution, the solution initially get converted into white color, as I initially told you in the reaction case. So chloride react with silver nitrate, then you have white colored precipitate. So this yellow color changes to white color precipitate, and finally this white colored precipitate changes into simply brick red, as the concentration of or as the addition of this silver nitrate goes on increases, all the chlorides that are present in that water sample are converted into brick red colored precipitate. So from this titration, we will see or observe that all the chloride ions get converted into silver chloride. Simply, the chloride ions are finished, and that's why the color of the solution turns into brick red. So this is the end point of the titration. So why this end point we have? Because the chromate ions start reacting with silver and forms silver chromate precipitate. So that's why we have these three different colors that I have shown you in the slide. Okay, so initially the water when react with chromate, it has yellow color. As soon as it starts react with silver nitrate, it get white color, it is of silver chloride. And when it get completely react with silver nitrate, is completely convert all chloride ions into silver chloride, then finally you will have the color brick red color. In this way, this is the end point of the titration. So during this titration, we have certain values of silver nitrate consume. So in that experiment, we take three different samples: sample A, sample B, and sample C. So put all the value that you have got in the during experiment. Suppose that here in this case, I consider that I got three different values of three different samples. Like for sample A, I require 2 ml of silver nitrate. For sample B, I use 3 ml of silver nitrate, and for sample C, 0.2 normal 0.2 ml of silver nitrate use. So in this way, after putting all the values in observation table, we will have to use the formulae which is given here for the calculation. So when we add all the values in the formula, we will have the amount of chloride content present within the water. So we will perform this experiment, or we will perform this procedure for or repeat this procedure for 3 times. For sample A, for sample B, for sample C, we take burette solution silver nitrate. In a conical flask, we take water sample with potassium chromate indicator, yellow colored solution obtain. This yellow color solution titrate, we have a brick red color precipitate. Then finally we will get this one, that is end point of the titration. So put all the values in the formula for sample A, for sample B, and for sample C. Suppose that if I calculate this for sample A, then chlorides in milligrams per liter, and put the value for sample A is 2 into 0.1 into 35.5 into 10. Then after making all the calculations, I have the value that is 71. This 2 is nothing but the burette reading, or the amount of silver nitrate consumed during titration. During titration, we use the silver nitrate, that value is nothing but 2, and the 71 ppm is the amount of chloride content present in the sample. So look at this, like this we will calculate all these three values of chloride content for sample A, for sample B, and for sample C. Suppose that for sample 1A is 71 ppm. Similarly, like that for sample B, it is 3. 3 is nothing but burette reading into 0.1 into 35.5 into 10. So we have 106.5. So this 106.5 indicate that the value indicate that the water sample is moderately hard. Okay, so for sample C, the chloride contents present is again we put the value, that is 0.2 into 0.1 into 35.5 into 10 is nothing but 7.1. It indicate that the sample C is very pure. It contain very less proportion of which one, that is chloride content. It means that it can be used for drinking purpose, it can be used for industrial application, because it contain very less proportion of which one, that is chloride content. So in this way, we will put all the values again in the observation table, and finally we will complete the observation table with remarks. So what are the remarks? Let us see that if the values are in between 0 to 50, that value, that water is soft. then simply after observing all these values, C sample has a value 7.1, so it is soft. If the value is 50 to 100, in between 50 to 100, then it is moderately soft. If 100 to 150, then it is moderately hard. It can be used for drinking. So we simply uh, write here sample A and B both are moderately soft. So after putting all the remarks in the observation table, we will make certain conclusion, and this conclusion is also based on this remark. So these remarks are very important. You should put all the remarks as per the WHO guidelines. It means that WHO make certain guidelines to decide whether that water is fit for drinking purpose or it is not fit for drinking purpose. So according to these guidelines, we will make these remarks. See that remarks are here 0 to 50 it is soft water, so simply it is fit for drinking purpose. If it is 50 to 100, it is moderately fit, moderately soft, it is fit for drinking purpose, or 100 to 150, so it is lightly hard, it can be used for drinking purpose. So as per these remarks, I have made the conclusion or result of this titration, that the water samples A, B and C, all three are fit for drinking purpose, because there is a lightly hard water which has value 106.5, so it can be used for drinking purpose. So I put here all these three samples are fit for drinking purpose. And the water samples checked by using these this method are very clear, very precise method, very simple method. So it is very useful method for determination of chloride content. So